Assalamualaikum students. Today I will discuss the very easy topic, which is the difference between the hard magnetic materials and the soft magnetic materials. I will discuss in my lecture the 9 points. Number 1 point is the hard magnetic materials cannot be easily magnetized. As you know, these are the hard, so that's why they cannot be easily magnetized. Soft magnetic material can be easily magnetized. They are soft, so that's why easily magnetized. Number 2, hard magnetic material can be produced by heating and sudden cooling. You have to heat the material and then suddenly cool. The sudden cooling can be applied by using the cooling gas like the nitrogen gas. And the soft magnetic material, it can be produced by heating and slow cooling. You have to heat the material and then slow cooling. You don't have to do anything. It will be cool on its own. Number 3 is the domain wall does not move easily and require large value of H for the magnetization for the hard magnetic materials. The domain wall do not move easily. I will discuss it in the next points. And you have to require the large value of H. I will discuss in the hesterisis loop area. I will show you the graph. And for the soft magnetic material, domain wall will move easily and require the small value of H for the magnetization. Number 4, hesterisis loop area is large. Susceptibility and permeability values are small. The loop area will be large, and the susceptibility in my previous lecture I also discussed the susceptibility and the permeability. Susceptibility is the response of the material to the applied magnetic field, and permeability is the resistance against the formation of the magnetic field. So the response and the resistance against the formation of the magnetic field, both the values are small for the hard magnetic material. And for the soft magnetic material, hesterisis loop area is small, susceptibility and permeability values are high. The response and the resistance to the magnetic field will be high. Retentivity and the corecivity is large. Retentivity and the corecivity are small. I will show you a graph. This is the graph between M and H magnetization and the magnetic field, and this is the curve, and area enclosed by this curve is the hesterisis loop area. Remnants are measure of the remaining magnetization when the deriving field is dropped to 0. When the deriving field is dropped to 0, and retentivity, you will take the retentivity in terms of intensity of the magnetic field. And here at this point we have the corecivity, and corecivity is the measure of the reverse magnetic field needed to derive the magnetization to 0 after being saturated. Needed to derive the magnetization. At this point the value of M is 0, magnetization to 0, and the reverse magnetic field, here the saturation is in this direction and the saturation here is in this direction. So the reverse magnetic field after being saturated, and remnant magnetization is equal to M naught, and the corecivity is equal to H naught, and the x-axis is the H, strength of the magnetizing signal. For the hard magnetic material, this loop area will be large, and for the soft magnetic material, this loop area will be small. I hope from the graph you understand the concept of hesterisis loop area, retentivity, corecivity, and the large value of H and the small value of H for the soft magnetic material. Number 6 point is high eddy current loss. The eddy current is the current induced by the varying magnetic field, and its loss will be high for the hard magnetic material, and the low eddy current loss will be for the soft magnetic material. Number 7 point is the impurities and defects will be more, and for the soft magnetic material, no impurities and defects. Number 8 point is the examples. The example of the hard magnetic material are the alnico, chromium, steel, tungsten steel, carbon steel, and the example for the soft magnetic materials are the iron silicon alloy, ferrous nickel alloy, ferrites, garnets. Number 9, uses. The hard magnetic material are used as the permanent magnets, DC magnets, and the soft magnetic material are used as the electromagnets, computer data storage, and the transformer core. I hope you understand the lecture clearly. Dear friends, your subscription is very important for the promotion of my channel, so please like, share and subscribe. I will be very thankful to you.